The shift to terrestrial bipedalism demanded radical anatomical reorganization from the Great Ape ancestor, which possessed an upright trunk posture and a short, shallow, and wide rib cage, but retained long arms and short legs. The 5 groups represent successive adaptations to changing African environments, particularly the shift from forested habitats to more open, arid grasslands.
To trace this epic journey, we will explore 6 key stages. We'll begin with the massive environmental shift that spurred our ancestors to change. From there, we will meet the very first pioneers of walking on 2 feet, examine their forest-dwelling cousins, and then get to know the highly successful gracile Australopiths. Next, we will look at a fascinating evolutionary side branch with the robust Paranthropans, before finally arriving at the dawn of our own genus, Homo.
Giving up a life in the trees for one on the ground was the fundamental challenge our ancient ancestors faced. Their bodies, which were built for climbing with long arms and short legs, had to undergo a radical transformation. This is the very core of our story, a series of incredible adaptations as Africa's dense forests began to recede, making way for vast, open grasslands.
This entire chain of events was set in motion by a changing climate. Millions of years ago, Africa began to cool and dry out. The vast, lush forests started to shrink, and in their place grew open woodlands and sprawling grasslands. This was much more than just a change in scenery. It was a new evolutionary proving ground.
To make sense of these changes, scientists have organized our ancestors into 5 major groups. You can think of each one as a distinct strategy for survival, defined by shared physical traits and their unique position on our complex family tree.
Our story really begins here, with the pioneers. Around 7 million years ago, we find the very first fossil evidence of creatures that were beginning to walk on 2 legs. We have 2 key examples from this period. First, Sahelanthropus chidensis, who lived in a forest and likely subsisted on soft fruits and leaves. And then there's Auroran tugenensis. Auroran presents a fascinating mix. It had thick tooth enamel, a trait we see in later hominins, but it also kept some very primitive features, like large canine teeth and parts of a honing complex. That's a mechanism where the back of the canine sharpens against the lower tooth, something common in apes but lost in later hominins.
You see, walking upright wasn't an overnight switch. The next group we encounter, living about 1 million years later, were truly masters of 2 worlds. They walked on the ground, but they were still very much at home up in the trees.
The prime example for this dual lifestyle is Ardipithecus ramidus, and we know so much about it thanks to a remarkably complete skeleton nicknamed Ardi.
And Ardi's anatomy is just this incredible mosaic of old and new. The way its spine connected to the skull clearly tells us it walked upright, and yet it was still a powerful climber. It had long arms and long, curved fingers, perfect for moving through branches. And maybe most striking of all, its big toe was divergent. It could grasp like a thumb. Its teeth also showed that it was still eating soft forest foods, not the tough vegetation of the open grasslands.
But eventually, a new group emerged that was more fully committed to life on the ground. These are the gracile Australopithecus. They were tremendously successful, and they represent a major step out of the forest and into the open savanna.
And when we talk about this group, the first thing that comes to mind is one of the most famous fossils ever discovered, Lucy, a member of the species Australopithecus afarensis.
Lucy's skeleton revealed so much about this group's lifestyle. They were habitual bipeds. We also see that males were much larger than females. But, interestingly, their sharp canine teeth were about the same size in both sexes. This might point to a shift in their social structure, with maybe less direct competition between males. Their teeth also show an adaptation to a harder diet, capable of processing the tougher foods found on the savanna.
Now, from these gracile Australopithecus, our family tree splits. One branch would eventually lead to us, but another took a completely different, highly specialized route. These are the robust Paranthropines, and they were, for all intents and purposes, the ultimate chewing machines.
The difference is dramatic. The Paranthropines built their entire anatomy around the act of chewing. They developed a huge ridge of bone on top of their skulls, the sagittal crest, to anchor enormous jaw muscles. Their molars became gigantic, so large they're called megadont. Their jaws were massive and their cheekbones flared out. They were specialists, perfectly adapted to grind down the toughest, most fibrous plants imaginable.
But while that robust line was investing everything in chewing power, another group of gracile hominins took a radically different path. Instead of evolving more powerful jaws, they started using bigger brains. This marks the beginning of our own genus, Homo.
Their new survival kit wasn't anatomical, it was technological. This is when we see the first widespread stone tool industry, known as the Oldowan tradition. These weren't complex tools, they were simple but revolutionary choppers and scrapers, tools that could smash open a bone for its marrow or slice meat from a carcass, unlocking a whole new world of high-energy food.
Early members of our genus, like Homo habilis, kept the smaller jaws and teeth of their gracile ancestors, but their brains were getting noticeably bigger. Their faces were becoming flatter, a bit more like our own. And critically, their fossils are consistently found right alongside those stone tools. This reliance on intellect and technology, rather than just physical might, was a fundamental pivot from purely physical adaptation to what we would call cultural adaptation.
When human beings developed language for communication, they could transfer information and knowledge to the next generation very efficiently. Thus, without any major genetic modification, modern human went well ahead of any other species in the battle of survival, because every generation did not have to start from scratch.